So today we have a 2011 F350 Super Duty with the gas engine. It's here for a stalling condition. He says occasionally it would stall idling, and sometimes on light acceleration it would stall. I drove it in the shop and it seemed to run fine, but we're going to scan it and see why the check engine light is on and see if there's any codes to give us a hint. Well, it's sitting here idling right now while I'm looking to load the vehicle, and it's stumbling. Let's go into the scanner here, and I've worked on this vehicle before, but not for this problem. But I can hear it laboring as if it's about to stall. So normally I would do a network scan, but I want to see what's going on here. Just going to go straight into the engine. I hear the AC is running. Let's see what kind of memory codes we have. Camshaft sensor. Really? I think it had the Evap code before. Evap system pressure sensor A, circuit range performance. Unless it's purging when it shouldn't be purging, but why has it got camshaft, crankshaft sensor range performance, not current, not current? So all of these codes are not current. I'm gonna have a look around, see what the freeze frame data has to offer. Maybe that'll give me a hint as to what tripped the last code. I hate when there's more than one code now. You don't know exactly which one to chase. I'm sure it's not the Evap, but it could be purging when it shouldn't be. Yeah, it's the Evap that set the last fault code. I wonder if it's purging from the, let's see, fuel trim, bank 1. Well, it was an open loop, so it wouldn't know. 1 second. System pressure sensor, so that's the pressure sensor on top of the tank being out of range from what I would gather. And that's nasty because this is a 1-ton dually flat deck welding truck, and I'm sure the tank's in the very back, and I'm sure that they didn't put an access hole to access the fuel pump, but I don't know for sure. Pressure sensors on top of the fuel pump assembly, and we have no fuel pressure sensor reading in this recording. Well, I'm going to save this recording and in case I need to look at it after. So having a look at the fuel tank pressure right now, it's showing negative 8 inches of water, which is very low pressure. I think, well, I'll put a correlation to PSI, but it's next to nothing. And it's dropping right now. It's not purging right now. Purge valve is closed. Unless it's purging when it shouldn't be, unless it's drawing vapor off the fuel tank all the time. I'm just going to go remove the gas cap. So I took the fuel cap off and it didn't change, so that pressure sensor is obviously skewed. Although I'm not sure where exactly that pressure sensor is. It may be on the charcoal canister and not on the top of the tank. I have to look at this. So I customized the data list here, and it shows that the purge solenoid is okay, vent solenoid is off. I don't know if it's normally closed or normally open. I think it's normally open. So there shouldn't be a negative pressure in the system right now, unless that purge valve is leaking. Now there's no fuel trim status in this data list, so I'm going to have a look at fuel trim right now and see if it's, theoretically, if it's purging right now when it shouldn't be, or if it's leaking, it should be running negative fuel trims. Where's short-term fuel trim? Well, but this short-term fuel trim of bank 1 is okay, unless the long-term has corrected now. Well, long-term trim is at -2% or -9% and -7%. I think we better find that purge solenoid and see if it's leaking. So there's the purge solenoid behind the air induction system. It's bolted right to the intake manifold. So we need to take that line off the back of it and see if there's vacuum felt on that line. So that's exactly what we're doing that. So I found it necessary to remove it completely from the intake manifold. There's two little 6mm bolts with 5/16 heads, 8mm heads, because I couldn't get the line to release. There's a quick release on it, you push it in, but it was full of sand, so it didn't want to release. So I'm going to stick the solenoid back in, and with the electrical plug unplugged, there should be no vacuum felt on this port. We'll have a look. So I'm about to start it, and I just realized what I should have done was just shut the vehicle off and check the fuel tank pressure status. Obviously, with the engine not running, there shouldn't be any kind of a negative pressure in the fuel tank. So as you can see, it's down to -16. So I got a feeling that pressure sensor is skewed. I got to find out where exactly it is. But I'm going to still check to see if we got vacuum on that purge solenoid. I'm going to start the engine and see if we have any kind of vacuum there. So the vacuum gauge didn't move, so there's no vacuum present there. I'm going to hook that solenoid back up and command the purge solenoid on. I'm going to command the purge solenoid on and see if we get vacuum there. Notice it's stumbling right now, almost as if it's starving for fuel or it's bleeding out or something. I'm going to command that solenoid on. We got vacuum on there at 20% purge, so solenoid's working. I'm going to command it off now. It may not leak off though, so I'd have to relieve the pressure in the system to see it. It's a brand new gauge, the hose don't want to come off. Oh my goodness sakes. Well, there's no vacuum there. Now that this purge solenoid is turned back off again. So that solenoid is working fine. Let's have a look at the fuel trims right now while it's kind of stumbling. So here it's idling now. It's kind of running okay right now. Long-term fuel trims on both banks at -7.7, which is within acceptable range. Usually plus or minus 10% is acceptable. Short-term fuel trim is at 0.8 on both banks. It's in closed loop. No reason for it to be stumbling the way it is. Mind you, it's kind of corrected itself now. Well, we got a couple of problems going on. I think we got a skewed pressure sensor on the Evap system, but that shouldn't make it run bad. Oh, maybe we'll have a look and see if there's any TSBs on it. So one of the codes in history was this P1336 crankshaft camshaft sensor range performance. It says the input signal to the powertrain control module from the crank sensor to the camshaft sensor is erratic. So it could be damaged crank sensor, damaged cam sensor, base engine concerns, which means loose timing chain, I would imagine, and harness concerns. The other codes that were in here were 369 and 394. So let's go back and see those one. B0. So here is the 369 code. PCM monitors cam circuit for an intermittent signal from the cam sensor on bank 1 sensor. Bank 1, sensor 2, vehicles with dual cam sensors per bank. For additional cam sensor location, refer to engine control components. See possible causes for 344. I hate the way Ford uses the same troublemaker charts for every application. You think when you ID the vehicle you're working on specific information. Intermittent open circuit, intermittent short circuit, damaged cam sensor shielding, incorrect harness connections, corrosion, damaged cam sensor. Oh boy. And the other code was 394. So I'll scroll forward to get to 394. I went too far. There's 394. Intermittent signal from cam sensor bank 2, sensor 2. Vehicles with dual cam sensors per bank for additional, same thing. So back to 344. Check harness routings, alterations, incorrect shielding, or electrical interference. Wonder if we should do a alternator diode ripple. Go to pinpoint test. Wow, if this is a key on engine running continuous memory code, they don't have any feet. This is a history code. And is it related to my problem? So here's a case on Identifix. It will run rough, sometimes stall, only at idle after deceleration event. Well, he said it would stall at an idle. Codes 0365, 369, and 394 are set in the PCM. Before extensive testing, inspect the crankshaft position sensor for rust buildup on the tip. See attached sensor location. Clean and replace the sensor if it is found. I believe the sensor is on the front of the crankshaft, behind the harmonic balancer. Oh, of course not. Really? See what it says here? The intake manifold must be removed to perform this procedure. Crankshaft position sensor must be positioned into the fitting on the crankshaft rear seal retainer plate and be flush against the block. What was wrong with when it was in the front of the harmonic balancer? Oh, engineering at its finest. This is what happened when a mechanic sleeps with an engineer's wife. He says, I'll fix those mechanics. Oh my God. Just now I know why the Ford guys take the cabs off the truck. So there's the alternator diode ripple. It doesn't look unusually terrible. There's some electrical noise in the circuit. I'm thinking we should lab scope the cam and crank signals here and see if we can see any anomalies or irregularities in the signals. So here's another case that I found on here, and it suggests base engine oil pressure could be at fault. Yeah, that's possible. I haven't checked the engine oil, but I'm sure it's pretty good. This guy's usually pretty good at keeping maintenance on his vehicle. Stretch timing chain, cam phasers, cam timing solenoids, VVT actuators. This is all looking rather nasty. That was on the 6.2 V8, same codes, 369, 394. In this case, both camshaft sensors were replaced. In this case, the crankshaft sensor was replaced. Well, let's have a look at the schematic and see where we can tap in and look at the crank and cam signals. So here is a picture of the camshaft sensors, their Hall effects, and the crankshaft position sensor is a magnetic pulse generator. So testing it at the crankshaft sensor is impossible because it's behind the intake manifold now. So looking like we're going to be testing it at the ECM. There's no connectors in between here that we could test at. I was just looking at this cylinder head temperature and the 2 knock sensors, C133, and it brings back fond memories of a 2014 that I was playing with, a 550 with a V10. Anyways, which connector is it? C175E, location, that's right at the computer, but which one would it be? Well, that's nice for it. A picture of the connector. Thank you very much. Which one of the 3 or 4 connectors on the ECM is it? Obviously it's the one going to the engine harness. So let's look at the connector view. Connector face. No, that ain't it. That's the wrong one. 175. Connector face. So it is 70 terminals. To give a color is black. So we'll see if we can figure out which one of the connectors that is. So 175E is this middle connector here. You can kind of tell because it goes towards the engine harness. I believe this connector here, whatever number it is, goes to the tranny, and this one goes to the smart junction box or the vehicle, the rest of the electrical from the vehicle. So this picture is the face side of the connector. So looking at it as it stands right there, it's just like that. So we need to back pin it. So we need to look at a mirror image of this. So pin 13, pin 37 and 38 are going to be the crank sensor, the cam sensor 1 and cam sensor 2. So we're going to reconnect this and attempt to back pin it. So I had to take the back off of the connector. Problem with this connector. I'm going to get some dielectric grease on that seal. So I've blown the sand out of this connector. And it's trying to go back in. There we go. So we're looking for 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I think it's that yellow one right there. This yellow one right here that is coming from the crank sensor. That one right there. Crank sensor is yellow and violet. I don't see any violet on that wire. Well, I'll get set up here. So I'm having some difficulty here. The third row down is 34, 35, 36, 37, 38, and those wires match. But the first row right up here, which is 17, 18, no, 17, 16, these numbers go up. They start at 1. There's actually numbers on here. You can see them on the back of here with the magnifying glass. That's 17 down at this end. So 17, 16, 15, 14. So it's this yellow wire right here that I have to back pin for the crank sensor. So I've got 3 channels connected. Channel 1 is connected to the crank sensor. Channel 2 is connected to the cam sensor 2. And channel 3 is connected to cam sensor 1. So I've got this thing hooked up to my Vent Veris Edge lab scope module, and we'll have a look at the waveforms now. Hopefully my back pins are making contact. I've got a 4-channel lab scope loaded here. I was recently using this to look at some cam and crank signals. Okay, I'm going to change this to 10 volts. It's an AC signal. And the other ones should be good at 10 volts as well, because they're, I would imagine, a 5 volt square wave. We'll put the trigger on channel 1 on the crank signal, see what kind of a signal that produces, 100 milliseconds. And let's turn off the cursors. We don't need the cursors right now. Okay, I'm going to start it up. So we've got some signals but no crank signal. I'm going to adjust these voltage amplitudes. I guess to see it better on here, probably 20 volts is good. But I've got no signal on the crankshaft sensor signal, so it might not be making contact. I'm going to go and play with that. Okay, so now we got a crank signal. I just had to manipulate my pin. Let's move these ones up a little bit so they're not interfering with it. Let's see if we can get that trigger. Really can't really trigger off that. Looks pretty clean. Let's change the time base and record it a little faster. There's one thing about snap-on scopes is you can zoom out, but you can't zoom in. So if you recorded at a very quick time base, a fairly quick time base, like it is right now, and then pause it, now you can zoom to see the recording. Looks pretty damn clean. So there's one revolution of the crankshaft. And there's the two cam signals, neither of which look poor or unusual. So I'm going to save a copy of this recording. So I don't see anything physically wrong with these signals. They look nice and clean. Mind you, the vehicle is running perfectly fine right now too. I'm a little suspicious of the amplitude of this crank signal because it's on in a 10 volt scale. Now I don't have the sensor, I'm not testing across the sensor, I'm testing on the crank signal positive, so it could be skewed a little bit. There may be a bias voltage on the sensor. In fact, there is a bias voltage on the sensor because look at here's the zero potential right here. Sorry, you can't see that maybe. The zero potential in that channel 1 is way down here. So there is a bias voltage on the crank sensor. And they do that for diagnostic purposes. Oh boy. I just don't want to throw a part at it, especially considering it's not a 5-minute job to change the crank sensor. If it was on the front of the crankshaft, I would consider it. So I tried to stabilize the waveforms a bit by triggering off of the secondary spark plug wire on number 1 cylinder, hoping to find a specific position where number 1 spark plug fires, but it doesn't appear to work. Although it does seem a bit more stable than if I trigger off of, say, that one there, and now it's floating across the screen quite dramatically. Whereas if I trigger on here, cylinder, it is significantly more stable. Still don't see anything wrong with this. Let's drop some cursors on here. Let's freeze it. Drop some cursors on here. Show the cursors. Close it. And let's see what the values are on the two signals here. Okay, 5 volts and 0.37. 5 volts and 0.37. So I don't think we have a bad ground on the Hall effects. They look nice and clean. Well, we'll let it run for a while, see if anything materializes. So I've added a fourth channel to look at alternator diode ripple at 500 millivolts with AC coupling turned on. And you can see there's a little bit of electrical interference in here. And I was recording this and I noticed every once in a while you'll see some electrical interference in the cam signals. Maybe if I pause this and then go back frame at a time, you'll see what I'm talking about here. Well, there was one right there. Oops, I clicked the wrong value. Notice this spike here. And sometimes it gets even worse than that. Now I don't know if that's a normal anomaly or if that's a problem. There was one there. Voltage spike. It shows up in the crank signal, the cam signal, shows up in everything. And it actually lines up with, well, somewhat lines up. Maybe it's wishful thinking. I wonder if we got a voltage regulator problem. It does say electromagnetic interference. Like, look at this one right here. You can see this one showed up in the crank signal, in both cam signals, and it shows up as a fluctuation on the voltage too. Oh, what was that? See, there it is again. Crank signal 2, cam signal 2, cam signal 1, and it shows up in the crank signal as an anomaly or a hash in here. I'm starting to wonder if I should just clean all the grounds on this thing and see if that makes any difference. So I just decided to look at the service history on this thing. It was here back in March, and he was complaining about the check engine light on. He had a wheel speed sensor issue, but this P1336 code was present back in March. So it's been there for a while, and I'm sure that that code has nothing to do with the random stalling. I'm sure it's crank sensor related, cam sensor related. So that was back in March of this year, and now it's here with that 451 code as well. So there is a problem with that pressure sensor on the Evap system, but I don't think that's got anything to do with the stalling, the random stall condition. I'm going to clean all the engine grounds on this thing and see if that makes it any cleaner. So here is the ECM has 3 grounds, or the PCM has 3 grounds at 103, G103. So if I click this hyperlink, it shows me where it is, right rear of engine compartment. Now I found 3 grounds on the firewall right beside the ECM. This is a shitty picture. Where is that? Doesn't show you the... I mean, come on. With digital photography the way it is today, can't we do better than this, Ford? My gosh. Where is that? Well, that's the only ground it shows, and I've cleaned them. I'll show you where those are. So there's 3 grounds that I found at the back of the engine bay. And one's a ground strap that goes to the back of the right cylinder head. Then I think this one is G103 right here, because it has like frickin' 6 or 7 wires going into it. Then there's another ground right beside it. So I've cleaned the battery cables, I've cleaned all those grounds. I'm going to spray paint them, and I've cleaned the positive cable and the positive feed wire from the alternator. I suppose we could clean the battery cable on the engine block, but I think that would affect the starter more than anything. Let's see if it makes any difference on the waveforms. So I don't know if it's just wishful thinking, but I'd like to think it looks a little cleaner, especially on the alternator waveform. I'm going to drop some cursors on here. Show cursors. Let's pause it. Let's see where we are on this signal and this signal. That didn't change, 0.37. The green one is 0.4, so the ground potential on the two cam sensors did not improve. It's still 0.3, 0.4. I'm going to record this for a few seconds and play back. So upon replaying this capture here, I still see voltage spikes that line up with the fluctuations of the system voltage, I think caused by the voltage regulator and the alternator. I'm going to disable the alternator and see if I still get these fluctuations or if they're coming from something else. You can see this voltage spike on the crank sensor lines up perfectly with this voltage spike in the battery. So I'm going to disable the alternator by disconnecting the output wire. So I've got the alternator output wire disconnected at the maxi fuse by the battery, so there's no alternator output now. Still got voltage fluctuations in the battery, but I'm not seeing, maybe it's wishful thinking, but I'm not seeing any significant spikes in here. I'm going to pause this and rewind it. So I'm still seeing a concurrent voltage spike occurring in all four channels, even with the alternator disabled, so that kind of eliminates the alternator and the voltage regulator. Let's see if I can find another one here. Now you can see in the crank signal and the two cam signals. There it is again. So you can see a negative spike on the crank signal, the two cam signals, and you see a voltage spike that lines up perfectly with the... So I'm going to see if I can figure out where that's coming from by putting another channel and moving this one around to other circuits. Maybe it's an ignition coil that's causing it. Damn. So here are the 8 ignition coils on this engine. They all share a common power supply. Comes through connector 1168, which is by the battery there, right by the ECM. So if we find this one single wire, we should be able to current ramp all the coils. I also noticed there are 2 ignition capacitors, one on each bank. Let's see this location of this connector. I think I saw the capacitor in there. So the connector is right there, and there's a capacitor on each side. So I wonder if one of those capacitors might be causing an issue. I wonder if we should current ramp the coils to make sure we don't have one coil that's shorted or something like that. I guess we can do that. That's easy enough to do. So that white connector that you see down here is 1168, and that violet wire in the corner, pin 1, is feeding power to all 8 of these ignition coils. So if we put a current clamp over that, and I still have my trigger on number 1 spark plug wire, I'm assuming this is number 1, 1, 2, 3, 4, 5, 6, 7, 8. I'll double check that. We should be able to current ramp all the coils and see if there's any anomalies in any of the coil currents. Well, this doesn't really make sense. That doesn't look like ignition coil current ramps. I'm sure I'm on the right wire, the violet wire on that pin, but they should go up like a sawtooth, like a triangle, unless there's injectors being driven off that circuit too. Let's pause this for a second. I realize why my secondary trigger is not syncing, because it's meant for conventional ignition, and that's waste spark. It has two spark plugs on the engine from what I can see, and a waste spark type coil, so I'm on the spark plug wire, probably negative firing, and I can't change that. If you look at the cylinder trigger, I can't select positive slope, I can only select negative slope, and if I go to manual, it doesn't allow me to do anything with this. So I gotta, that's why it's floating across the screen and hasn't synced, because it should have synced and I couldn't figure out why it didn't. But regardless, let's pause this, let's zoom it and see how many firing events we have in one engine revolution. Where to go? Well, hang on, I'll get it back. So we're back. So there's one engine revolution. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So something else is, I must be on the wrong wire. So it helps if you're on the right connector. There turns out to be another gray connector, a black connector below this one. The one I was on goes going down to the transmission harness. I should have realized that. So that's why we weren't getting a reading on that. Let's adjust. I can't go higher than 20 amps on that circuit. So now we can see ignition coil, and this is a double fire, so it's firing the coils twice at a low RPM. I want to see if there's anything different in these waveforms. So I'll record it for a few seconds here and I'll zoom it up. So that makes sense now. So there's one revolution of the crankshaft and 4 ignition coils firing. It takes 2 revolutions of the crankshaft for all 8 coils to fire. So they all look relatively the same. Don't see any unique different coil. So this particular coil firing event seems to coincide with the voltage spikes that are occurring in the crank and cam signals. But it's not there on every one of them. See, there's no voltage spike on that one. That one's clean. That one's clean. That one looks good. That one looks decent. There's a bit of a spike on that one. I wonder if we can isolate which coil it is. We can't use the number 1 trigger because the polarity is wrong on the spark plug wire. I guess I'll have to trigger off the control side of number 1 coil. So there's number 1 ignition coil synced with the current ramp event. So you can see this would be number 1's coil's current ramp and the rest would be in the firing order. I can see this one here seems to be consistently generating a voltage spike that shows up. I've used channel 1, which was on the crank sensor before. I've got it connected to the number 1 spark plug now. Now you can see this coil ramp event tends to line up perfectly with this electrical anomaly here. I'm going to analyze this a bit. So this is cylinder number 1 firing, and this is the current ramp on the coils. You can see when the coil turns on, and the voltage goes low, and then the voltage spike occurs. So this next one in the firing order is the cylinder that appears to be creating electrical interference with the cam and crank sensors. If I scroll through here, you'll see the other cylinders seem to be okay. There it is again. So the question now is, what cylinder fires after number 1? Well, let's have a look. Firing order is 13726548. So that's the third cylinder on the passenger side. So we got an option now. We could either move the coil or trigger on that one and see if, let's trigger on that one, that's faster, and see if that's actually the coil that seems to be creating the electrical interference. 1, 3. Too bad I can't scroll through this faster. 7, 2, 6, 5, 4, 8, 1, 3. So we'll move the trigger over to number 3 and see how theoretically this event would line up with that coil firing. So I moved it to number 3. That's the third cylinder on the right side, and that looks perfectly fine now. Let's pause this and rewind it. See if we see any electrical anomalies. There's 2 there, there's 4 there, there's 6 there, there's 8 there. But I want to show you what I found. I'm going to see if I can reproduce this. Okay, here's what I found. This wiring harness, which contains all of the wires going into that connector, cam, crank, signals, all that, is normally, that's number 3 ignition coil down there. I got my hand on. I'm going to back probe it. When I went to plug this in, I noticed that this harness was right up against the coil. Right against the coil. So I moved it like this in order to gain access, and the problem went away. So I'm going to put that harness back where it was again. It was sitting right against the coil connector. And of course, there's electromagnetic interference theoretically from that coil that would generate signal anomalies. And I'm going to trigger off of the number 1 again and see if that problem comes back. So even though I moved the harness back in close proximity to that coil and moved my trigger back to number 1, well, there's a little bit that appears there once in a while. Yeah, there it is. Every once in a while you get a signal in there. Let's see if I can pick it up. A little bit there. Anyways, I'm going to move that harness and then we're going to run it. Well, we're still consistently picking up the odd spike that's affecting the signals, even though I moved the harness away from the coil, and it seems to line up consistently with cylinder number 3. So I'm going to replace cylinder number 3 coil. There it is again. Well, that one wasn't there. And maybe put a set of spark plugs in it while we're here. That should be fun. I wonder if these are like the 5.4s that don't come out and break off. We'll have a look. That's interesting. I noticed the check engine light on. And I know this 620 code is caused by me disconnecting the alternator, but I had cleared all the codes. 1336. I don't know if that was the code that was there before. Yes, 1336 came back. So is it picking up electrical interference from that coil, or is it a failing crank sensor? I'm going to change the coil and maybe do a set of spark plugs in this thing, and I'll do a follow-up to see if that fixes the problem, or if we're going to end up putting a crank sensor in this. Interesting, right from Ford it says the setting conditions for P1336 are engine running, PCM detected an erratic signal from the crank sensor or from the cam sensor. Note that it is possible for EMI, RFI interference to cause this code if they occur on the crank or cam sensor signal circuits. Interesting. Well, we're going to change out that coil. Going to probably sell them a set of spark plugs too, considering the mileage on the vehicle, and I don't know if they've ever been changed. And then hope for the best. I'll post a follow-up video, or I'll post a follow-up to let you guys know if this corrected the problem or not.